Welcome to this ASP.NET Core MVC tutorial. In this course, we are going to build a full-feature web app called NextWatch AI that helps you discover and manage your favorite movies. Here is what it offers. On the homepage, you'll see a list of popular movies pulled live from the TMDB API. You can add any movie to your favorites and search for a specific title. In the AI Power Recommendations section, you can describe your mood and the app will suggest a movie using the OpenAI API. Finally, there is a favorite section where you can view all the movies you've saved along with any personal notes you've added. We are building this project with a modern development stack. .NET 9 Visual Studio Code, Docker, SQL Server, and Entity Framework, all structured in a clean, maintainable architecture that's designed for easy extension. This course is designed for a wide range of developers. Beginners are welcome, especially if you're ready to challenge yourself. Intermediate developers will get hands-on experience with real-world architecture, and advanced developers will appreciate how we apply clean architecture principles and integrate external APIs like TMDB and OpenAI. You will get the most out of this series if you're familiar with web development concepts, things like HTTP, HTML, CSS, and some C# fundamentals. Here is a clear overview of what we'll build together. We'll start by setting up an ASP.NET Core MVC project using the identity template. So we have user registration and login ready from the start. Then we'll integrate the TMDB API to search and display popular movies. After that, we'll bring in the OpenAI API to recommend movies based on mood. Next, we'll move into backend work, designing the database to support favorites and notes, and implementing that using Entity Framework Core with full CRUD operations. Finally, we'll store all this data in a SQL Server database running inside Docker to keep the environment consistent and cross-platform. Before we jump into the code, I want you to learn some key concepts to help you understand ASP.NET Core MVC application, starting with the MVC pattern, its backbone. First, the model represents our data. In our case, a movie, its title, director, and release year, and it's often what we store in the database. Second, the view handles presentation. It is what the user sees on the screen, like a movie list page or favorite page. Finally, the controller is the bridge between the two. It handles user requests, decides what data to fetch, and picks which view to show. This separation of concerns makes our code cleaner, easier to maintain, and more scalable. Now, to make these concepts clearer, let's walk through a simple example that brings MVC to life. Let's start with a model. Here we have a simple movie class. It holds the data we care about, things like the movie's title, the director, and the release year. This is kind of data that later on we'll typically store in the database. Next, we have the view, represented here by the movie view class. The view is responsible for presenting information to the user. In this example, the display movie method prints the movie's details to the console. In a real web application, this would be your Razor page or HTML template. Finally, we have the controller, here the movie controller class. The controller connects the model and the view. It takes the movie object and the movie view, and it tells view to display the movie. In a real ASP.NET app, this is where you'd handle user requests, process input, and decide which view to show. In our main method, we create a new movie, for example, Inception by Christopher Nolan. Then we create the view and the controller. Finally, we call update view on the controller, which triggers the view to display the movie details. Now that we've tested our code and seen it working, let's take a moment to improve its structure and apply some clean architecture principles. Clean architecture is about organizing our code by responsibility, not just technology. We separate it into clear, meaningful layers so core business logic, like how we manage movies, stays independent from details like the user interface or database. This makes the application easier to scale, easier to test, and much easier to maintain as it grows. Let's break this into layers. At the center, we have the model layer. This is our pure data, like movies, with no dependencies on anything else. Around that, we have the controller layer. It contains the application logic and depends on the model. Finally, we have the view layer. It handles presentation. It depends on a model and is coordinated by the controller. A key role in clean architecture is that dependencies flow inward only, meaning the outer layer knows about the inner layers, but never the other way around. For example, the view can use the model, but the model should never reach out to the view. Now that we covered the concepts, let's apply clean architecture to our code. Right now, all our classes, the model, controller, and view are sitting together inside the program.cs file. This works for a small demo, but it quickly becomes unmanageable as the app grows. First, we'll create 3 folders: models, controllers, and views. These match the layers we discussed earlier and help us organize code by responsibility. I'm moving the movie class now into the model folder since it holds our core data. Next, the movie controller goes into the controllers folder. This is where we keep our logic and coordination code. And finally, the movie view goes into the views folder, responsible for displaying the movie information. Just like we discussed on the slides, notice the flow of dependencies here. The model has no dependencies, it's pure data. The controller depends on both the model and the view. And the view depends only on the model. Keeping this inward dependency flow is what gives clean architecture its flexibility. Now that we've organized our code into clean architecture layers, let's take it one step further and make it more flexible. We'll do this using a key concept called dependency injection. Dependency injection means we provide dependencies, like services or helpers from the outside. Instead of locking our classes to one implementation, they depend on interfaces, abstract contracts. This improves flexibility, making testing easier, and lets us swap or mock parts of the system without rewriting core logic. As an example, right now our view directly logs movie details to the console. But what if tomorrow we want to log to a file, send logs to a server, or even turn off logging entirely? Hard-coding this logic makes our system rigid and harder to maintain. We need a flexible solution, and that's where dependency injection comes in. To make this possible, we'll define an iLogger interface. It will describe what it means to log without caring how it's done. Then we'll create 2 implementations, a console logger that logs to the console, and a file logger that writes logs to a file. Finally, we'll inject this logger into our movie view so that view no longer hardcodes the logging method. This makes our system more flexible, easier to test, and much easier to extend later. To apply these concepts, first I'm creating an iLogger interface. This interface defines a simple contract, a log method that takes a message string. The key point here is that the interface doesn't care how the logging happens. It just says, I need something that can log messages. This sets the foundation for flexible and interchangeable logging. Next, I'm creating a console logger class. This class implements the iLogger interface and writes messages directly to console using console.writeLine. With this, we now have our first working logger implementation, and we can already log messages to the console. Now I'm adding a file logger class. This one also implements iLogger, but instead of writing to the console, it writes log messages to a text file like log.txt. This nicely demonstrates how easy it is to switch between different logging behaviors, all thanks to the interface abstraction we set up earlier. To keep the project clean and well organized, I'm going to move each of these classes into its own file. I'll also create a services folder to group them together. This kind of structure helps keeps the codebase manageable, especially as it grows. With our loggers in place, it's time to prepare the movie view to use them. I'm going to update the movie view class so that it no longer writes directly to the console. Instead, it will accept an iLogger instance through the constructor, store it in a private field, and call logger.log whenever it needs to display something. This change removes the hard-coded console dependency and makes the view much more flexible. Now let's test everything. In the main program, I'm going to create a logger. I'll start with the console logger and inject it into the movie view when we create it. When we run the application, you'll see that everything works just like before, and the movie details are logged to the console. But here's where the power of interfaces really shine. Because the movie view only knows about the iLogger interface, it doesn't care which logger we inject. That means we can easily swap up the logger for any other implementation without changing the rest of the code. To demonstrate that, I'm now going to switch the logger to the file logger. With just one line of code change in the main program, the entire system now logs to a file instead of the console, and no other class needs to change. We can open the log.txt file and see the movie details were successfully written there. This perfectly shows the beauty of programming to interface and how dependency injection makes your system flexible, testable, and easy to extend. Now let's shift from the internal structure of a web app to how it interacts with users through URLs, endpoints, and routes. A URL is the address you type in the browser, like movies/details/5. It tells the web server which page or resource you want. It can include a path like movies/details and sometimes parameters like the movie ID, which is 5 here. An endpoint is a piece of code that handles a request for a specific URL. When someone visits a URL, the server looks for the endpoint connected to it and runs the code. In ASP.NET Core MVC, endpoints usually live in controllers as action methods. A route is a rule that tells the framework how to connect a URL pattern to an endpoint. It defines which code runs when a particular URL is requested. Routes can include placeholders like ID, so they can handle dynamic URLs like movies/details/5. The URL movies/details/5 matches the route pattern movies/details/ID. The route system passes the value 5 to the details endpoint inside movie controller. This is how ASP.NET Core knows which code to run when you visit a specific page. We've now laid a strong conceptual foundation. We understand MVC, clean architecture, the power of dependency injection, as well as how URLs, endpoints, and routing fit into the picture. We've seen how these ideas work in a small example. Now we are ready to move forward and apply them to build a real full-feature web application. Next, watch AI. Before we write any code, let's make sure our development environment is ready. First, we need to install the latest .NET SDK. .NET is a free open source developer platform from Microsoft used to build many types of applications. For this tutorial, I'm using .NET 9. You can download the .NET SDK from the official Microsoft website. Just go to download and get the latest stable SDK for your operating system. I'm using Visual Studio Code, so if you're using VS Code, you can follow along with me step by step. If you're on Visual Studio, no worries, the steps are almost identical. The Visual Studio has most of the tools and templates built in right out of the box, so you're already set up to follow along. In VS Code, here are the main extensions I recommend. C# Dev Kit gives us C# language support, IntelliSense, debugging, and project management. C# extensions adds extra C# productivity tools like code snippets and syntax highlighting. And NuGet Package Manager. It's optional, but it gives you a nice UI inside VS Code to search for and install NuGet packages. Without it, you can still install packages using terminal with .NET Add Package, but we'll be using this later to install libraries like Entity Framework. Once you've got those installed, we're ready to create a new ASP.NET Core MVC project and start coding. To create our project, I'll be using the command palette in VS Code. This is a convenient tool that lets us run commands without leaving the editor. You can find it under View. And start by searching for .NET:new project. For the project template, choose MVC, Modal View Controller. This sets up the folder structure, controllers, views, and models we need for an ASP.NET Core MVC app. Next, create a folder and give it a name. Then give your project a name. For authentication, I'll select individual accounts. ASP.NET Core then sets up a powerful identity system behind the scene. It gives us ready-to-use pages for registering, logging in, and managing user accounts. This is built on top of ASP.NET Core Identity, a secure, battle-tested membership system. It also creates the backend database table to store user information, which we can later use to extend the app with features like user-specific favorite movies. Once that's done, we're ready to run the app and see the default setup in action. You'll notice that we already have login and register pages available. That's because we set up the project using the individual user identity template, which automatically scaffolded the necessary authentication pages for us. Now I'm going to create a new user account and login, and we're all set to start working inside the app. Now we are going to build one of the core features of Next-Watch AI, fetching a list of popular movies from TMDB and showing them on our homepage. We are using TMDB, the Movie Database API, because it's a widely trusted free API with huge catalog of movies, TV shows, posters, and metadata. To use it, go to their website, create a free developer account, and generate an API key in your account settings. This key is required on every request. Without it, the API will reject your calls. Hard coding the API key into code is a bad idea. It's insecure and hard to maintain. Instead, we store it in app settings.json like this. We include both the API key and the base URL to centralize our configuration. Later, we'll access this using ASP.NET Core's iConfiguration system. Before hitting the API, we need to know what to expect back. If you check the TMDB API docs, the movies/popular endpoint returns JSON like this. Results is a list of movie objects. Each movie has different properties like ID, title, overview, and poster path. And top level, we have page and total pages. You can test this yourself using Postman or the REST client extension in VS Code like me. Just paste in the API URL, set your query parameters, and hit send. This helps you understand the data format before you write code. Next, we define C# classes that mirror this JSON structure. At the top level, we create a TMDB movie list response class, which includes page, total pages, and a results list. Each item in results is a TMDB movie which we define as a separate class. In TMDB movie, we include only the fields we care about, like ID, title, overview, and poster path. We apply JSON property name attribute to correctly map JSON names to our C# properties. This makes deserialization seamless and gives us clean, strongly typed data to work with. Once we have the data, we don't pass raw TMDB objects to the view. Instead, we map them to a view model, in this case, movie VM. In ASP.NET Core MVC, a view model shapes the data specifically for the UI. Even though movie VM looks almost identical to the TMDB movie right now, it gives us two key benefits. It separates external data from the UI, protecting us from the backend changes, and it gives us flexibility to prepare data for the view, like turning poster underscore path into a full poster URL. This keeps the view simple and focused only on display logic. Since our view may also need additional information, like the total number of result pages for pagination, we will wrap the list of movie VM objects into another class called movie list result. This view model contains both the list of movies and the total pages value from the API, giving the view everything it needs in one well-structured object. Now we create the actual service, TMDB movie service. We inject HTTP client instead of creating it manually, because it is designed to be reused. Creating new instances risks socket exhaustion. By injecting it through dependency injection, ASP.NET Core manages its lifetime efficiently. We also inject iConfiguration to access our setting in appsetting.json. This is a practical use of the dependency injection concepts we covered earlier in this course. Then we write an async method that returns a task of movie list result. Anytime we perform I/O operations like HTTP requests or database calls, we use async and task to avoid blocking threads. This improves scalability, especially under load. Then inside the try-catch block, we use URI builder to safely build URLs with query parameters, avoiding common string concatenation bugs. Now this line calls the TMDB API and deserializes the JSON into a TMDB movie list response object which we created earlier. We then transform the result into ViewModels, combining things like poster path with full image URL, so the view doesn't need to handle formatting or API details. Finally, in program.cs, we register the service so ASP.NET Core can automatically inject it when needed. You might be wondering, shouldn't we be using an interface like iMovie service, like iLogger, which we use in our previous example? In production apps, using an interface is best practice. It lets you swap implementations, mock services in unit tests, or even switch to local cache. But here, for this tutorial, we have only one service and no plans to replace it. So adding an interface would just create extra boilerplate without real benefits. That said, you should absolutely consider interfaces in larger or production-grade projects. Alright, now that we have our TMDB service ready, it's time to connect it to the controller layer of our application. This is important because it is the first time we are formally working with controllers. So let's slow down and understand exactly what's happening here. In ASP.NET Core MVC, a controller is a part of your application that handles incoming HTTP requests, decides what data to process or retrieve, and ultimately prepares a response, usually by passing data to a view. You can think of the controller as the traffic director of the app. It sits between the user's request and the backend services and views. In the default template, we already have a home controller, so we don't need to create one from scratch. Let's open home controller and walk through it. Firstly, why is it called home controller? In ASP.NET Core MVC, convention over configuration is a key principle. The name home controller matters because the framework looks for a controller that matches the first part of a URL. For example, when a user navigates to home/index, it automatically maps to the home controller class, the index action inside it. If no controller is specified in the URL, it defaults to the home controller and index action, and this can be changed in program.cs. So naming your controller correctly is essential for routing to work automatically. Notice that home controller inherits from controller, which is a base class in ASP.NET Core. This gives us access to key methods like view, redirect to action, JSON, and more. It also connects this controller to the MVC routing system. To display popular movies on the homepage, we first inject our TMDB movie service. Because we registered it in program.cs earlier, the dependency injection system automatically provides an instance of the service when the controller is created. This gives our controller access to all the TMDB fetching logic without tightly coupling the layers. iActionResult is the standard return type of controller actions. It is an interface that represents the result of an HTTP request, which could be a view, a redirect, a JSON data, a file, a status code, and more. We define the return type as task of iActionResult because we are using async calls. This ensures our controller stays responsive, non-blocking, and scalable. We also accept the page number as an optional parameter that defaults to 1. Next, we call TMDB movie service to fetch the data. View data is a simple dictionary that lets you pass small pieces of information from the controller to the view, especially useful when you don't want to overload the model. In this case, we pass the current page number and total pages so that Razor View can render pagination control. Finally, we return the view like this. It looks for a view called index.cshtml inside the view/home folder. It passes result.movies, a list of movie VM objects, as the model to the view. Now that our controller is fetching movie data from the API, it's time to pass the data to the view and render it on a page. This is the first time we're working directly with the view layer in ASP.NET Core MVC. So let's make sure we understand the big picture before jumping into the code. In MVC Model View Controller, the view is responsible for displaying data to the user. It does not handle business logic, data fetching, or validation. It's purely for rendering output. We use Razor syntax here, a blend of HTML and C#, which makes it easy to embed server-side logic right into our markup. Each controller action, like index, looks for a corresponding CSHTML file in a matching folder. So for example, home controller.index looks for view/home/index.cshtml. As you can see in our controller logic, we pass a list of movie VMs into the view. So the view will receive a model of this type. Now let's open this file. At the top of the Razor file, we need to declare the model like this. This tells Razor what type of data we're expecting, and it enables full IntelliSense in VS Code. This is great for speeding up development. Now, instead of hand-coding a big HTML table from scratch to show popular movies, which is time-consuming and honestly not the best use of your energy, I recommend you to use AI to generate a first draft. Here you can see the prompt I personally used in Copilot chat, or you can use it in GPT as well. I have also included all the prompts, commands, and any other important snippets I use in this video in a GitHub file. You'll find the link down in the description. Now I apply this draft to page and fill it dynamically. This way you can save time and you can customize it later. Also, you can learn from the structure it gives you because knowing some HTML and CSS is still mandatory. Now it's time to wire up this template using Razor. Let's walk through how this works line by line. Let's find the T-body section and inject C# code that loops through the movie list and renders each row. Here is how that looks. @ for each is how we loop over every movie in the list. Inside the loop, we write standard HTML for each table, row, and column. For the poster, we add a little logic. This makes sure we don't show a broken image if the URL is null. @ movie title and @ movie overview output values directly. The action column just shows a placeholder button for now. We're not wiring it up yet, but having it in place helps us with layout and future planning. And for pagination, we have a previous button, the current page number, and a next button. At the top, we extract the current and total pages value from view data dictionary. These were set in the controller, and having access to them help the view to know what page we are on and how many pages exist. Going back to the bottom of the page, to the pagination section, this is how the markup will look like with Razor value injected. We disable the previous button on page 1 and the next button on the last page, using ternary expressions in Razor. The ASP action and ASP route page syntax is part of tag helpers, a feature in Razor that generates correct URLs automatically based on the controller action logic. And here we show the actual page number. Let's clean up template, give the page correct title, and run the project. And as you can see, everything is working as expected. Now let's start building our AI power recommendation feature. And as always, we'll do it step by step with clean architecture in mind. Just like what we did with TMDB service, we'll begin by defining result model before implementing the logic. Let's define the structured data we want from our AI engine. We'll create a class called AI recommendation result, located in the models folder. This class represents the full AI response. That includes the original mood the user entered, the movie title GPT recommended, and a reasoning string where GPT explains in a natural language why the movie fits the mood. This separation of concerns is essential. Even though GPT returns plain text, we want to parse and wrap it into predictable, strongly typed structure. Now let's define an interface, because this time we want flexibility. Unlike the TMDB service, where we always call one public API, here we might want to swap up OpenAI later for another LLM provider, replace it with a local model, or mock it entirely during testing. So by starting with an interface, we decouple our app from the implementation. This interface defines just one method. It accepts a string input, the user's mood. It returns a task of type AI recommendation result, an asynchronous result wrapped in a custom type we control. We'll implement this interface in a service class soon, but for now, this is the entry point to our AI feature. To follow along with this feature, viewers will need to access to the OpenAI API. Here's what you need to do first. Go to platform.openai.com, log in or create a free account. In the dashboard, click on API keys, create a new secret key. Copy this key and store it securely in appsetting.json like this. And remember not to commit this key to a version control. You have also included a model name as a config value. This makes it easy to switch between models like GPT 3.5 or GPT-4 without touching our code. This keeps our service configurable and secure. Alright, we've defined the interface and result model for our AI recommendation system. Now let's implement the logic that actually talks to the OpenAI API. We'll call this class GPT Recommendation Service, and we'll put it in a services folder. First, install the OpenAI SDK via NuGet. Now at the top of the file, bring in the necessary namespaces. Then we implement the interface we created earlier. And we inject configuration using the constructor. We pull the API key and model from appsetting.json using dependency injection. If either value is missing, we throw a clear error saying argument null exception. This makes debugging easier. Next, we create an instance of chat client, which is the OpenAI SDK class for chat-based interactions. By storing chat client as a private field, we avoid creating a new client every time the method is called. Recommend movie async is where the user's input is sent to GPT and we parse the response that we receive back. Step 1, we create the prompt. The system prompt tells GPT how to behave. It keeps response consistent. The user prompt is a mood input like I feel nostalgic or I'm in a mood for something thrilling. Step 2 is build a chat request. This creates the full conversation history we send to the model. Step 3 is where we call the OpenAI API. And here is what each option means. Temperature is a parameter that makes GPT more creative. Lower means more factual. And max output token count limits response size. In step 4, we parse the response. We split the string under pipe character and then extract movie title and explanation, as you can see. If the split fails, we throw a format exception. This protects us from malformed GPT responses. Step 5, we return the structure result. This converts the raw GPT output into a strongly typed model we can safely use in the controller or view. We also add a catch block at the end, so this ensures that if anything goes wrong, API key issues, format problems, network errors, the app doesn't crash. Instead, we return a graceful fallback result with the error message. Now that we've implemented our AI recommendation service, it's time to connect it to the user interface. We are going to create a new controller that will accept the user's mood as input, send the mood to our AI service, and display the return movie recommendation along with the reasoning directly in the view. Let's get started. Inside the controller folder, create a new controller called recommendation controller. We'll inject the AI service just like we did with TMDB, but this time we're using an interface. Let's talk about HTTP post attribute on the ask method. This is a key part of building forms in ASP.NET Core MVC. When the user fills out the form and clicks submit, their mood string is sent as form data. ASP.NET automatically binds the form input to the mood parameter right here. Then we call our AI service. This fetches the movie title and reasoning from OpenAI based on the user's mood. We store the data in view data and return the same view. The result, the page reloads, now showing the AI's recommendation. In a real-world app, we typically take the movie title written by GPT and send it to TMDB using our existing service. That would allow us to show the movie poster, a full overview, rating, and release date. But to keep this tutorial short and focused, we are skipping that for now. The full version in the GitHub repo does include the logic. There is even a search bar in the final project. But for now, I want to focus to stay on what's new. Before anything works, we need to tell ASP.NET Core how to inject our GPT recommendation service whenever a controller asks for AI recommendation service. Here's how we do that in program.cs. In ASP.NET Core, services are registered with a lifetime. This controls how long the object lives and when it's reused. There are three main lifetimes. Add singleton creates one single instance for the entire lifetime of the application. We are using this for our AI service because it's lightweight. The chat client views under the hood doesn't need to be recreated. It's safe to share across requests, controllers, and users, and it improves performance. No need to reinitialize anything with every request. There is also add scoped, which creates one instance per HTTP request. Use this when your service depends on per-user data like session state or needs to reset with every web request. Think of scenarios like shopping carts or database unit of work patterns. Finally, there is add transient. Creates a new instance every time it's requested. This works best for lightweight, stateless services, or when you need full isolation. But be careful, if your service needs setup, recreating it too often can be wasteful. And that's it. With your controller wired up and the service registered, your app is ready to start making AI-powered movie recommendations based on users' mood. Let's move to the next step. Inside Views folder, create a recommendation folder and add an empty Razor page called index to it. It is a simple page that shows a form to enter mood and displays the AI's recommendation. We use Razor code to set the page title to AI recommendation and retrieve two values from view data, the title and the reasoning string. These values will be used in the view for display. Now I'm using GitHub Copilot to generate a Bootstrap style form that posts the user mood to the ask action in our recommendation controller. I also prompt Copilot to include logic that checks if the title and reasoning values exist, and if so, display them in a clean and style layout using strong and EM tags. This is a great way to speed up development, focus on architecture, and still keep full control of the final result. To test all of this, we also need a new nav button to take us to this newly created page. For that, open Layout Add the new nav item and make sure you set ASP controller, ASP action, and also title correctly. Now we are ready to test the app. Let's go to our AI recommendation section. I'll add a prompt. I'm in a mood of a good mystery. And as you can see, we're getting the result back. The movie title and also the description of the movie. Now we have reached a major chapter in our application. Up until now, we've been fetching and displaying data from external APIs like TMDB and OpenAI. But now we are moving into storing user-specific data. And that means we need our own database, our own schema, and our own logic. This is where Entity Framework Core or EF Core comes in. EF Core is the official Object Relational Mapper ORM for .NET. It allows us to represent our database schema using C# classes, query and update the database using link, and perform schema updates using something called migrations. We don't write raw SQL, we let EF Core generate it from our model. So here is what we are going to build. When a logged in user sees a popular movie, they can click Add to Favorites. That movie is saved in a table called Favorites, linked to both the user and the movie. Later, they can see their list of favorite movies and even leave a personal note. Before we begin wiring up the Add to feature, we first need to establish the database foundation. This is where relational data modeling comes into play, a critical concept in modern web application. Let's zoom out for a moment and look at the big picture. What you see here is our ERD, or Entity Relationship Diagram, a visual representation of our database schema. We'll be using tools like dbdiagram.io to create and visualize this structure. It's a foundational step in designing data for any application, helping ensure that relationships between entities are clearly defined and scalable. Let's break down each table. ASP.NET Users. This table comes from ASP.NET Identity, which we already enabled when we created the project using the individual user accounts option. We did not create this table ourselves, it was generated automatically by EF Core and Identity. It stores all your registered users, including ID, email, password hash, and other fields like email confirmation, lockout, 2FA, etc. When a user registers or logs in through our app, they're stored here, and we can link other data to their user ID. Movies table. This is our local movie cache. Even though we get movies from TMDB when a user favorites one, we store a simplified version here. Movie ID is primary key. Title, poster URL, overview are basic fields for display. Also, we store TMDB ID in case we want to track back to TMDB later. This makes favorite retrieval faster and more reliable, and lets us enrich the data later with notes, tags, or other local features. Favorites. This is a conjunctional table. It connects a user to a movie with optional metadata like personal note. This pattern is sometimes called a junction table or linking table, and is how we model a many-to-many relationship with extra fields. In this case, one user can have many favorite movies, and one movie can be favorited by many users. Now that we've seen our database structure visually in the ERD, let's translate this into real C# classes. We'll do this using Entity Framework Core's code-first approach, meaning we define our tables as C# classes, and EF Core builds the database from them. We'll start by building two entity classes, movie.cs and favorite.cs. Movie ID is the primary key. EF Core will automatically recognize it because it ends in ID, but will still configure it explicitly later using Fluent API. TMDB ID field to track which movie it came from. Title marked with required attribute, which tells EF this field cannot be null in the database. Poster URL and overview, these are optional fields. That's why we use nullable string, which allows null values. This class gives us a minimal but usable representation of a movie. Favorite class, it maps directly to our favorites table in our diagram. You'll see required on both user ID and movie ID. This tells EF Core these values must always be present. We don't allow a favorite without a user or without a movie. This ensures a referential integrity, and EF will apply these rules both in the code and in the database schema it generates. In this class, you'll notice something called navigation properties, like user and movie. These don't appear as columns in database. Instead, they act as bridges, letting us move from one related entity to another in our code. Why is it useful? Imagine we've pulled a favorite record from the database. Thanks to these navigation properties, we can directly access details from the related movie, like its title or poster, or even the user's email address. It feels seamless, just dot notation in the code, but under the hood, Entity Framework Core is executing optimized SQL joins for us. Let's now take a closer look at one of the most foundational pieces in any ASP.NET Core application, the application DB context. This class is where we define how our data is structured, how tables relate to each other, and what rules our databases should follow. So what is application DB context? In EF Core, application DB context is our gateway to the database. It inherits from a base class called Identity DB context, which gives us user authentication features like login, registration, and password management, and it acts as a central hub for all tables or entities in our app. This class does two main things. First, it registers the entities we want to track in the database using dbset. Second, it allows us to configure relationships and rules between those entities using something called the Fluent API. So let's get into step one, registering our tables. Here we add these two lines. This tells EF Core I want a table called movies and another table called favorites. Their structure will be based on my C# classes named movie and favorite. Once we add these and run a migration, EF Core will create those tables in our database automatically. As for second step, we apply Fluent API configuration, and it's where we precisely define how our tables work. Let's go through this line by line. This defines the primary key for favorites table. While EF Core can often figure this out on its own, we explicitly define it for clarity and safety, especially when dealing with relationships. Now, this is one of the most important lines in this entire block. We're saying a user can't favorite the same movie more than once. This creates a unique constraint in the database across both user ID and movie ID, preventing duplicates. We can't express this kind of rule with simple attribute, and it is vital for our data integrity. This line tells EF Core that the note field is optional. If we didn't specify this, EF might assume all string fields are required and enforce that in the database. So we are saying the user can leave a note with a favorite movie, but it's totally optional. This means each favorite is tied to one user. We are not defining a collection of favorites inside the user model just yet. That's what with many implies. And if a user is deleted, all their favorites should also be deleted. This is called cascade delete. Same idea here. If a movie is ever deleted, maybe during cleanup or admin tools, All linked favorites are also removed. So when do we use this Fluent API? Whenever we want to define unique constraints, customize relationships, handling deletion rules, configure composite keys, or add rules that can't be expressed inside the model class. You could write some of this using attributes inside the model classes like required or key attribute, but those only go so far. When your data model becomes more complex, like ours, Fluent API becomes necessary. It also keeps your model clean and your schema logic centralized. Before we run our first migration and actually apply our schema to a database, let's pause and talk about something very important, the extra development tools we need to use here. If you're on Windows using Visual Studio, you don't need Docker. Just make sure you have SQL Server installed, either SQL Server Express or SQL Server Developer Edition. And also SQL Server Management Studio, SSMS, to manage your database. Once these are installed, SQL Server runs natively on your machine, and EF Core can connect to it directly. And you can skip next step to install Docker. But if you're Mac and VS Code, since SQL Server doesn't run natively on Mac OS, we'll use a Docker to spin up a SQL Server container locally. In order to achieve this, first you need to install Docker Desktop. You can download it from docker.com website. And once it's installed, launch Docker and keep it running in the background. Next, you need to run SQL Server in a Docker. I'm running this using this command, since I'm on a Mac with Apple chip. I'll paste the exact command in the resource file for this tutorial. I'll also include a link to the official Microsoft documentation in case you need to adjust it based on your setup or your Docker image version. You can set your admin password here, expose the SQL port here, and assigning a name makes the container easy to reference. And D runs it in the background. If you open your Docker app now, you will see that the container is up and running. Next, make sure you install these required packages. Entity Framework Core, Entity Framework Core.SQL Server, Entity Framework Core.Tools, and Entity Framework Core.Design. These let EF Core talk to SQL Server and manage migration. At this point, open your app setting.json and add a connection string like this. The values here, such as server, database name, username, and password, should match your own setup. Whether you're using the Docker, a local SQL server on Windows, or something else, feel free to update these details based on how you've configured your environment. Next, register your DB context in program.cs. This line tells your application to use Entity Framework Core with SQL Server, and it pulls the connection string from your app setting.json file. This is what connects your app to the database when it runs. Now, as an optional step, if you're in VS Code, you can install MS SQL extension by Microsoft, and this helps you visually inspect tables and run queries inside the VS Code. That's your setup. Whether you're on Windows or Mac OS, you're now ready to run migrations and start building with Entity Framework Core. Before we continue, make sure you're only using one database provider in your project. For example, if you're using SQLite, do not also register SQL Server in the same app, and vice versa. Entity Framework Core doesn't allow multiple providers for the same DB context, and it will throw an error if you try. So you can just pick SQL Server and remove SQLite to follow along with this tutorial. Also, because we want to start totally fresh, we're going to drop our existing database and wipe out everything. This gives us a clean slate to build our identity tables and feature tables from scratch. Just keep in mind you need to register user again. Now that we've defined our entities, movie and favorite, and configured them using Fluent API in application DB context, it is time to actually create the tables in our database. This process happens in 2 steps. Step 1 is creating a migration. We'll use a feature in EF Core called Migrations, which allows us to version control our database schema. Let's open the terminal, make sure you are inside project folder, and run this command. So let's break this down. .NEF is a command line tool for entity framework. Migrations add creates a new migration file. And add movies and favorites is just a name. You can name it anything that describes the change and is meaningful. Behind the scene, EF Core will scan our current models and configurations, compare them to what's already in the database or previous migration, and generate a C# migration file in migrations folder. This file includes all the instructions to build the movies and favorites table, apply relationships, and enforce our constraints. You don't have to edit this file. EF takes care of everything. And step 2 is to apply the migration to the database. Now let's update the database using this command. This tells EF Core apply all migrations that haven't been applied yet. EF will connect to the database using the connection string from your app-setting.json and create the new tables. If you're running SQL Server in Docker, as we set up earlier, make sure your container is running first, then rerun the command. Once it's done, your movies and favorites tables are now live in your local SQL Server database. You can inspect the database using any external database tools such as Azure Data Studio, DBware, or SQL Server Management Studio, or the SQL Server extension in VS Code. In order to connect, you'll need to paste your connection string first, and then you have access to your database. Now that we've completed our first migration and the favorites table is live in the database, it's time to let users actually add movies to their favorites from the home page. That means when someone clicks Add to Favorite, we'll store the movie for the currently logged in user. Right now, our home controller doesn't have any user-related logic, so let's change that. We are going to create a new action in the home controller to handle post request from Add to Favorite button. But first, we need 2 important dependencies. Application DB context. This gives us access to read and write data from our database. User manager is part of ASP.NET Identity. This lets us interact with the currently logged in user, access their details, and manage their identity securely. And now it's time to create our new action. First, it has a validate anti-forgery token attribute. What is it? This attribute is a built-in security feature that protects against cross-site request forgery or CSRF. Basically, it ensures that form requests actually come from your own site and not from a malicious third party. ASP.NET Core automatically includes a hidden anti-forgery token in every Razor form, and this attribute tells the controller to expect and validate it. Now it's time to handle the post logic. Inside our new method, we do the following. First, check if user is logged in, because only authenticated users should be able to add to favorites. Next, get the user's ID from the identity system and check if movie already exists in the local database. Now here's something interesting. What if the movie isn't there yet? Then we will try to fetch the movie by its ID. And let's talk about this since this method isn't part of our service yet, but it's time to add this. We've already used the TMDB API to get popular movies. Now we are expanding our service to include a method that fetches a single movie by its ID. So we go to our TMDB movie service and implement that new method. Now, anytime a user tries to favorite a movie that we haven't stored yet, we can automatically fetch it from TMDB using ID and add it to our database safely and reliably. Now back in the controller, we check if the user already favorited that movie. If not, we add it to the favorites list. This ensures clean data, no duplicate favorites, trustworthy movie info because it comes from TMDB, not the browser. In our home index, we now need to update the Add to Favorites button to actually submit the data. We do this by wrapping it in a form and including a hidden field that passes the movie ID to the backend. This invisible form field doesn't show up in the UI, but it gets submitted with the form when the user clicks that button. This is a standard pattern. Use hidden fields to securely pass small pieces of data to your backend without exposing them in the interface. The final step is to test it out. If I'm not logged in, I can't add a movie, exactly what we want. When I log in, click Add Favorites and check the database. I can see a new entry in the Favorites table with the correct user ID and the movie link together. Everything is working as expected. And that wraps up this part of the tutorial. We've securely handled adding favorites, integrated TMDB fallback logic, and wired it all up to our front end. In the last section, we added the Add to Favorite button and stored the movie for the current user in the Favorites table. Now we want to give users their own favorite page where they can see all the movies they've saved, remove movies they no longer want, and edit their personal notes. Let's start on the backend by creating a new controller. In the controllers folder, create a new file. This controller will be secured with authorized attribute, so only logged in users can access it. It also uses dependency injection to get application DB context for database access and user manager to identify the current user. Once the controller is set up, we can begin adding logic. In this step, we're listing the current user's favorite movies. Let's walk through the code together. Before we can return the data to the view, we need a custom view model to carry just the fields we need. This class inherits from movie VM and adds two extra properties. Favorite ID, which uniquely identifies the favorite entry, and note, which stores any personal notes the user has added. By using this view model, we can shape exactly the data we want to send to the Razor view, nothing more, nothing less. Back to the controller, we use user manager.getUserAsync to get the currently logged in user. If the user isn't found, perhaps they're not logged in, we redirect them to the home page. We query the favorites table and filter the results to only include entries where the user ID matches the current user's ID. An important line is here. This tells Entity Framework Core to eagerly load the related movie entity for each favorite. Why does this work? In our favorite entity class, we declared a navigation property called movie. This defines a relationship between favorite and movie. The include method ensures the related data is fetched, similar to an explicit join in SQL. Without include, the movie property would remain null even though the foreign key exists in the database. Use .select here to project each favorite into a favorite movie VM, a custom view model. This shapes just the data we need, the movie's ID, title, overview, poster, and any note that user added. This approach keeps the Razor view lean and avoids passing full EF entities, enhancing both performance and security. Finally, we return the view, passing it the list of favorite movie VMs objects. These are the objects we loop through in a Razor view to display the table. This is the delete action, responsible for removing a favorite movie for the current user. We retrieve the logged in user to ensure the operation is authorized. We look up the movie by its TMDB ID, not our internal primary key. Once we find a movie, we query the favorites table to locate the user's corresponding favorite using their user ID and the movie's internal movie ID. If a favorite is found, we remove it and call save changes async, a straightforward delete operation. Notice the return URL parameter at the top. This allows us to redirect the user back to the page they came from. If return URL is passed, we use it. If not, we fall back to index, and if that's missing, we redirect to the site root. This gives us better control over user flow. This last one is edit note action. It handles form submissions when a user edits a note on one of their favorite movies. We get the currently logged in user using user manager get user async. You've seen this before. It ensures every update is securely tied to the correct user. We query the favorites table and find a matching record using the favorite ID and user ID. This ensures users can only update their own notes. If a matching favorite is found, we update its note property using the posted form value. And finally, we call save changes async to persist the update and redirect the user back to the index page. Let's now create an index page for our favorite section. We'll define the Modal works with and receive data from the controller. By now, we are already familiar with Razor syntax and dynamic tables. We've used them in previous views like our popular movies list. For the favorites view, the table structure is similar, but with a few key differences. We've added a column to display user notes for each movie. And instead of the Add to Favorites button, we now have two actions, delete and edit note. The delete button is already set up and wired to the controller. It posts to the delete action in the favorites controller, the same pattern we used previously when adding a movie to favorites. There's nothing complex here. The form simply passes the necessary data using ASP route parameters along with anti-forgery protection. When submitted, it tells the controller which favorite entry to remove. With that in place, let's now focus on how we handle editing a note. And for that, we're using a modal. A modal is a pop-up dialog that appears on top of current page, dimming the background and preventing other interactions until it's closed or submitted. In our case, the modal contains a form, allowing users to quickly edit a note inline without navigating to a separate page. This approach improves the overall user experience by keeping the interaction smooth and focused. To create the modal, I'll use GitHub Copilot. Simply enter the following prompt and insert the generated code at the bottom of your browser page. However, since modals might be new to you and they rely on some JavaScript to function properly, let's take a moment to break it down. You can read the Copilot generated explanation as a starting point, but I'm going to highlight the critical concepts that you actually need to understand. This modal isn't just for display. It contains a form that posts data back to the server. The form uses ASP controller and ASP action attributes to map directly to a specific endpoint. In this case, the edit node action in the favorite controller. Now here's the key part. The form includes a hidden input for the movie's ID, which gets populated dynamically when the user clicks Edit Node. That allows the form to submit the correct ID back to the controller, telling it which record to update. It also includes a text area for the node itself, which is also filled in dynamically before the modal opens. So this setup creates a clean, in-place editing experience with the modal acting as a lightweight targeted form submission tool. Now that we covered the structure of the modal and how the form submits data back to the controller, let's complete the picture with the JavaScript that powers it. This script runs inside the @sign section scripts block, which ensures it's loaded after the modal and page content have been rendered. Let's walk through it. This grabs a reference to the modal elements on the page, identified by its ID, so we can hook into its behavior. Here we are listening for the show.bs.modal event, which is fired by Bootstrap just before the modal is displayed. This gives us a perfect opportunity to inject custom data into the modal each time it opens. And this line grabs the button that triggered the modal, for example, an edit node button that user clicked. Bootstrap automatically provides this reference via event.related_target. This line extracts values from custom data attributes on the button. favID gives us the ID of the movie or favorite entry. Title gives us the movie title, which we'll use in the modal header. Node pulls in the correct node or default to an empty string if it's not set. Now we will populate the modal with the data. The hidden input, favID input, is filled with the movie's ID, so it's included in the form submission. The text area is pre-filled with the existing node, and the modal title is updated dynamically to reflect the selected movie, giving the user context. This script is what makes the modal content-aware, pulling the right data at the right time, so users can edit their nodes smoothly without page reloads or extra clicks. Together, this setup, the modal, the form, and JavaScript creates a polished interactive experience that feels modern and efficient. Now the last step is actually to connect these to our table. To do that, we'll add a button inside each row for the table that represents favorite movie. This button will trigger the modal and pass along the necessary data, the favorite ID, the movie title, and the existing node, if there is one. Here's what that looks like. Let's break it down. Data BS toggle tells the Bootstrap that this button will open a modal. Database target specifies which modal to open, in this case, the one we've already built. The custom data favID, data title, and data node attributes carry the dynamic data this button needs to pass into the modal. When the user clicks this button, Bootstrap opens the modal, and our JavaScript listens for that event, extracts these values, and injects them into the modal's form in real time. With this in place, each row in your favorites table becomes editable cleanly, intuitively, and without needing to reload the page or navigating away. This is a simple yet powerful pattern you'll use again and again when working with forms and dynamic data in modern web applications. Lastly, we'll need a new navigation button that can take us to this newly created favorites index page. Let's add it. And now we are ready to test everything. You will see that our new navigation button will work as expected. We can see the list of movies that we have favorited before. We can delete any of them, and we will be able to leave a note. And this will conclude our CRUD operations. And that brings us to the end of this tutorial. Together we built something real, something complete. We didn't just follow a template or paste random code from the internet. We designed a full feature movie app powered by ASP.NET Core MVC, clean architecture, external APIs like TMDB, OpenAI integration for mood-based recommendations, entity framework with real migrations, and even containerized SQL Server using Docker, all while working entirely in VS Code on a Mac. That was the goal from the beginning, to show you how to build something that's modern, professional, and deployable. And we kept it minimal where it mattered. No unnecessary boilerplate, just real architecture and good practices. If you head over to Copilot and ask it about building a movie recommendation app, you'll now understand how to refine or even improve on its suggestions because you've actually built one from scratch. You'll also find a cleaner version of this project with a few extra touches available on GitHub, like cleaner styles, extra validations, and enhancements you can explore. You can check that out at the link in the description. That same repo also includes a resources.md file with everything we use throughout this video. Commands, Docker scripts, VS Code extensions, Copilot prompts, and every little trick I mentioned in passing. I hope this tutorial didn't just show you how to build something, I hope it gave you the confidence to take a clean idea, break it into pieces, and build it the right way. Thanks for sticking with me, I'll see you in the next one.